Welcome to Pavithra Laptop Care. Today's session is very important because so many technicians facing the problem, the only one major problem is no display. Even they are getting the core, then also they won't be able to get the display. In that case, what are the things we need to check? Actually, I multiple times I explained this, but anyway, once again I am going to explain to our PLC student who are finished our crash courses. Okay, see, first thing is what are the input and what are the output. Those things we have to check. First thing is DC in is the first input, charging IC is the first IC, final IC is processor. That is the output section IC. Means processor also a kind of IC. Okay, see, this IC is connected, means processor is connected to the graphic chipsets NVIDIA. Here, once NVIDIA is connected to the particular sock, this display unit will be primary and processor display will be secondary. If this particular graphic chipset has connected to the processor, I mean normal motherboard, in that case the processor will access the display related signals from this particular chip and it will work. The RAM has connected to the processor, so it will access data and clock through the RAM section. See, this is unidirectionally connected to the HDMI, CRT and EDP signals. These all are connected to the CPU, and remaining what are the connections are there? USB, flash ROM, LAN, Wi-Fi, SATA, ODD, everything is related to the PCH platform, controller hub. In this platform you can able to see the USB, IO, touchpad, so many things. See here from 1 to 13 pages is belongs to the SOC. Okay, SOC. It has connected processor and PCH. See here, what I told, it's unidirectionally connected to the HDMI section. See, these are the HDMI section. How it will connect? First, it will transfer the signal for the particular component. See, it's a TX2, TX1, TX0, TX. All are, it's from 0 to 3. Here, 3 part is connected to the HDMI from the CPU. Same thing, EDP also, see, TX. It's not bidirectionally. Bidirectionally only works in case of clock and data. See here auxiliary and auxiliary AX is connected to the CPU. It's bidirectionally working with the EDP section. See, in case of no display, you are getting light, I mean caps lock in the keyboard, but there will be no display in the main screen. In that case, you need to check this one, CPU communication path. Okay, see here, EDP, here HDMI is over. See, this is the section, HDMI data clock. Here EDP signals, EDP transmitter and receivers will be there. So receivers in the EDP section, and here it's a transmission section. Here only 2 transmissions are there. So here the signal path, EDP, SDP. See, if they have given here, some logic will be there. Through the logic circuits only as they have given this output. Where is that logic circuit? Here we can see in the particular pages. See, EDP this. If you obtain this particular signal, we should connect that 1.8 VS pull up to this one. And one more logic as given here. See, from the 33 pages, CPU, EDP, HDD, this signal comes to this particular MOSFET, then here you won't get anything. So we need to check thoroughly what are the signals and what are the configuration, I mean what are the functions of this particular signal. Okay, here only summary I want to give. See, this signal will pass to that particular section. Here something has given. See, it's a 3VS. That one is a pull-up for data and clock, VGA DDC graphics. This is for CRT and this is CRT reference. These all are pulled down. Okay. Now again we'll come to the EDP section. So one is HDMI over and second thing is EDP section. If any fault will come in EDP section, then you need to check this bidirectional things is working or not, or this transmission is happening or not, those things. Okay, so then these all are LCD, VDD, backlight and backlight. See, so many times you will get dim display. So For that, what are the reason and what are the control system will be there, that thing you can check in this path. See here, PCH backlight controller, somewhere here only in this particular page only has given, so that we need to check. Where is that backlight? We need to search here. Yes, see, backlight enable. If this signal comes, what will be the logic circuit and how it will works, everything I already explained, so need not to explain once again. So here is the PCH enable. Okay, this is very important thing, so you need to understand what are those. See these things. Okay, now if you are getting light on the keyboard but you are not getting the display, you need to check these sections. In case of HDMI is not working properly, this is the HDMI clock and data, those things you need to check properly. See, it's a positive and negative and positive path. So in this particular page, that's it. So it has connected with the HDMI and EDP. Second thing is, see, this is very important section. See, here it has connected RAM section. Completely it has connected RAM. See, DSLR accessing the data from the register which is located in the RAM. See, the path bidirectionally it has connected. DDRA, DQ 0 to 63. That's why multiple pins are there in the RAM section. But one thing you have to understand, some signals will pass through this particular CPU. See, what are those? RAS, CAS, VH, BS0 hash, BS1 hash, BS2 hash. Okay, slowly you need to check where it has gone, and it has gone to RAM section, RAM slot section, and it's available or not. These things you need to check. DSLR must. Once clock enable comes, then only the access of this, the data from the register, it will access. Okay, this one processor is giving to the RAM section. These are very important things, because once these sections are okay, clock, everything is enabled, one time the DRAM RST signal will goes from the CPU to RAM section. Once this DRAM section means, DRAM RST means what? Related to the RAM section, all voltage should be pakka. Once it's okay, then one time it will reset. One time in the sense, there should be voltage. The RAM voltage should be there in that particular signal. It's a 1.2, depends on RAM. That signal should be disabled. Okay, if enables, definitely your motherboard will be in no display case. One time only it will enable, and immediately it will go to the disable mode. It will be in fraction of a second it will work. So that's why you can't able to see. In DSO you can capture those things. So it means one time it has to go to 0 position, and again it should be in high position. So always the voltage should be there in DRAM RST. See, this is the output section. Output in the section in the means final section. After you are getting these all are signals. Clock enable, CS, this is the first one, CS channel selection 1, 2. So 2 dim will be there, no? Those things you need to check. See, this is the 1, 2. Okay. So now you come to know, we already discussed multiple times regarding this, so you need to remind. Okay. So next, see, these are the group wise the data will collect. The CPU will collect the data from the RAM, random access memory. DDR core, power good, okay, power okay, system power okay. This logic already explained. So which power okay is coming or not, those things practically you already checked. So see this reference, right? Okay, you have to take care of those signals, because this section is very important. Next, in this section, so 1.8 volts. See, one more thing you have to keep it in your mind. What are the voltages required for SOC? See, SOC having 1.8 Vs, 3 Vs, and here 3 volts always 1.35. These are the voltage path should go to the processor section. Then only it will work properly. If you are getting 1.35 always and 3 volts always 1.35 volts and you are not getting 1.8, then there will be no use, because it's the output section, everything should be pakka. See, here some logics are there for LAN request, clock request, WAN clock request. Once a request passed, then only your Wi-Fi will work or LAN will work. Here is the processor hot information. Okay, here 1 volts has given. See, this is too important. It's a 1 volt should be there. It's a pull-up voltage. If you are not getting this pull-up voltage, processor definitely it will be in off condition because of heat. If there is no heat, then also the information goes to the processor. It has heat. See, it's ODD detect. Here is the ODD section. What is this section? Here is the SATA. See, here is the HDD. Here hard disk, it will access through the SATA path. It's a transmit, already explained, positive, negative, positive, negative, positive, negative. It's a ODD path. It receives and transmits. See, here processor receiving. From where? From the ODD section, TX. Okay, it's accessing from the particular component. See, ODD or HDD. ODD detection, ODD DA. If you won't get here voltage, so definitely your ODD won't detect. Which one? DVD writer. Here, see, 1.8 volts. It has pull up to this reset button. PMC is power management controller systems reset button. See, once all power is okay, then this reset will enable within a microseconds. It will go to disable mode. Here is the AC and AC present. See, I already explained. Here you have to note down these signals. AC in. The adapter information has gone to PMC AC in section. It's not only in IO section. Even CPU also will get the AC in section. See, without this AC in, this logic circuit won't happen. Clock SI CS0. See, SPI section. SPI in the sense which one? It's a bias section. Once you write the bias, see, through this path the bias instructions will go to the CPU. Firmware. PLT RST. See, everyone wants this one, platform reset. When it will happen? Once related all signals and voltages are good, so then this logic will happen. See, if this voltage will come, then here it's the ground and here it won't active, then 3 Vs goes to the PLT RST. Someone was asking what the voltage we are getting in the PLT RST. Here is the practically you can check. 3 Vs goes to here. If any problem with the PLT RST signals, so you need to check the signals and these two MOSFETs. Okay, this is the key point here. If this MOSFET enables, you won't get PLT RST. Okay, here see suswarn. This is also very important signal. The logic multiple times I already told you. Sus clock. See, sus clock, once related all signals and platform controller signal also reset up, and then sus clock will come and the clock will enable, the CPU clock will enable. And here see, once RSM RST comes, then its SLP S3 S4 will release through these signals. The pull up voltage is 3 volts always. It's initial stage. When IO communicate with the PCH, that time PCH will give these signals. Here power out, same thing. See the power out. See in this page, so multiple signals are there. You need to take care about those things. See lead out, this also very important. Regarding the signals, I will make a video, so in that you can easily understand. RTC RST, see one more important section here. Too important, please keep it in your mind. Once this VCC RTC is gone to 0 and again it has to come back to the original position, means it has to be disabled. If it's not disabling, definitely your motherboard has gone. First you check all related capacitors or resistors or what are the connecting part, everything you can check. If it is good, then it's okay. After the good also, your motherboard will on pressing power button one time, and if you restart it, it won't turn on. It will be in dead condition. In that time, you need to check this part. If this part you are not getting any voltage, so think about it, your motherboard has gone, because here the PCH supply has completely dead. It's completely in open position, so there will be no reset continuously will be on. See, it's ash means it's a disable, it has to be disabled. One time enable and second time it has to be disabled. But here permanently if it is a disable, so then every time you need to discharge the complete voltage in the motherboard and then you need to on it, then only it will work one time. See, sock keyboard, lead, SMI, these are the bias, comparator, RTC RST, and here RTC CRTC RST. See, in this page too many signals are there, so you need to take care about those things. Is present over. So this part is RTC, SPI and PM, power management. So power management, SPI, RTC, those are very important. Once you get the disable SRTC, VCC, then 100% your motherboard will be in dead condition. Here this are USB section. Bidirectionally it has connected to direct USB. LPC, see, this also very important section. See guys, you will be getting no display. After getting the core voltage also, after getting the PLT also, you are getting the no display. This is a very important. This is LPC bus. These all should be there in the, you can check in the DSO. Here communication should happen, then only you will get the display, otherwise there will be no display. RAM is good, RAM section, all pins are good, all communication path are good, everything is good, but you are not getting any signals in this, so definitely no display case you will get. This one also request thing also should be there. PCM, SM data and clock alert, these are the important part. PCH beep, you will get the beep, right? So here is a signal. See how many resets are there, PXS resets. There is no only 2-3 reset signals, multiple are there, that thoroughly you need to check. See CMOS on, see this part also you need to check, CMOS sections. PCH, Bluetooth, VGA gate, data clock, it's a S3, clock and data, the input path is here, what is that, 1.8 volts. After this, it's carrying through the 3 volts VS bidirectionally. Request, sock request, this IC also very important, this has to come, okay. It's carrying 2 voltages, out of this which one it is carrying, that you have to check. See, it's a board ID, PCB ID sections. Here is the graphic conversions, guys. See, I already explained you multiple times, again I am going to explain. See, here it's a OPT, it's a display, discrete. Here it's a UMA. See, in case of if you want to disable the graphics card, then you need to shift this particular register to here, because UMA has given here. UMA will be in pull down, not pull up. Some people what they will do, they will put both the registers, so you should not do that one. Any one, it should be high or it should be low. In case of if it is a high, in that time the graphics will be enabled. In case of low, UMA will be enabled. Here one more reset, already explained that. These pull up voltages are very important. First you need to check this side, the input side and output. If you are not getting output, then there will be 2 issues. One is that particular register issue, otherwise this side, this path having low position. If you won't get, don't worry, first you need to understand the logic, so then you come to know. I told you in no display cases what are the things you need to check. See, here is the voltages to the PCH sock, 1.35, please note down, 1.35 GFX core. After this, the VCC sense, see, it's going to page number 59, it means it's CPU IC, okay. See, if core comes, then through the pull up VCC sense is going. Once GFX core comes, the voltage comes, then through the pull up this particular signal is passing. This one is ground, it should be there. If ground not there, your motherboard won't get shut down. Okay, CPU core, GFX core, RAM voltage. Next, CPU has connected multiple capacitors, and here see, it's too important. All voltage should go to the power management section. See 1.3, 1.5, 1.8, 3.3, 1.8, 3.3 VSS-AD, 1.05 VCC RTC, and here 1. See, multiple times you are asking, right, what are the voltage required to this particular CPU? See, this is the section you need to check. If the any one voltage is missing, definitely no display case or the clock won't generate. If clock generate also, the particular some sections won't work. In case of this section, this particular 1.05 VS is short, then you need to check these capacitors. Okay, it has connected. See, behind, other side of the CPU, you can see the multiple capacitors has connected. These are the important voltages. Pull up resistor. See 1.8 VS. Through this pull up or through the voltage divider, this signal will pass. Just you have to identify those signals where it has gone and from where it has come, and what is the required thing. PCH me protect I2C transmission. Okay, these are straps one. Okay guys, it's finished. These are RAM section. So now what we discussed from the beginning to the end of the particular page, main thing is some reset signals, some request signals, some bidirectional signals, some clock data. Those things what I explained here, those are important. After you getting everything, so if you are not getting that AD0s to AD45 something, I explained everything. If you are not getting those things, so definitely there will be no display. In that time, you need to heat the processor and check. If it works, fine, otherwise we can't do anything. And what are the steps I have to follow? Those things I already explained. Okay, that's it in this class. Thank you very much.